SF6, sulfur hexafluoride, has been used in electrical equipment for over 40 years. But for many people, SF6 is a relatively new and unknown product. In recent years, SF6 gas has gained increased use as a dielectric and an arc-quenching medium in a variety of high-voltage applications, including circuit breakers, load break switches, and substation bus. With change come questions, especially for personnel charged with handling the product. The purpose of this program is to answer some of the more commonly asked questions about the properties of SF6: personal protection, safe handling, cleanup, and disposal. The first part of this program looks at the properties of SF6, including the physical characteristics of SF6, the effects of heat and moisture on SF6, and potential hazards of the gas and its decomposition products if they are not handled properly. SF6 is like many other chemicals that are used every day in industry. If it's handled properly, it presents no injury or illness problems. If it's handled carelessly or improperly, under certain conditions, health hazards may exist. In order to handle SF6 properly, personnel must know the properties of the gas and its potential hazards. Clean sulfur hexafluoride is colorless. It has no odor. It's non-toxic and non-flammable. It's also 5 times denser than air, and it is one of the heaviest known gases. Because it is denser than air, SF6 will collect in low places, whether the low places are inside equipment, outside, or in buildings. Where it collects, SF6 displaces oxygen, and it can cause suffocation without warning. Other properties of SF6 are its excellent dielectric strength and arc-quenching capabilities. The SF6 molecule consists of 1 sulfur atom and 6 fluorine atoms, and it is usually pictured as a symmetrical double pyramid. When arcing occurs, the extreme heat of the arc forces the fluorine and sulfur atoms apart. However, the SF6 atoms are very good at transporting heat energy, and they carry heat away from the arc zone as they separate. This quickly cools and quenches the arc. After the arc is extinguished, the molecules recombine into their original stable SF6 structure. Many of the questions about SF6 have to do with its decomposition products. Anytime atoms of SF6 molecules are forced apart, the gas is said to have decomposed, and SF6 decomposes primarily as a result of heat. However, when the heat source is removed, most of the decomposed SF6 molecules recombine. Those that don't may combine with other molecules to form decomposition products. Decomposition products are created when decomposed SF6 reacts with vaporized metals or with moisture. Very tiny particles of metal, primarily contact surfaces, are vaporized under the intense but brief heat of the arcing that occurs when a switching device is operated. Decomposed SF6 reacts with the vaporized metal to form primary decomposition products. These may include powdery products such as metal fluorides. They may also include gas products such as carbon tetrafluoride and sulfur tetrafluoride. More substantial quantities of metals may be vaporized by internal fault arcs. This would result in higher quantities of decomposition products. Secondary decomposition products are created when decomposed SF6 reacts with moisture or when primary decomposition products react with moisture. The biggest sources of moisture in gas-insulated equipment are adsorbed moisture and absorbed moisture. Adsorbed moisture is water molecules that stick on the inside surfaces of the equipment. Adsorbed moisture is not visible. It doesn't appear as condensation, but the amount of adsorbed moisture can be significant. Absorbed moisture is water molecules that penetrate into the inside surfaces of the equipment. Absorbed moisture can also be significant. As the equipment warms, even from night to day, and seasonal temperature changes, both the adsorbed water molecules and the absorbed water molecules can condense and mix with the SF6 gas. Decomposed SF6 and primary decomposition products react with moisture to form toxic and corrosive powdery compounds and gases. These secondary decomposition products may include hydrofluoric acid, sulfur dioxide, sulfur trioxide, hydrogen fluoride, and a number of other potentially harmful decomposition products. Exposure to SF6 decomposition products can result in various reactions. Skin contact with the decomposition powder can cause rashes and severe irritation. Inhaling airborne powder can cause breathing difficulties, and with prolonged exposure, damage to the respiratory system. Airborne powder can also cause eye irritation. Decomposition gases smell like rotten eggs. Prolonged inhaling of these gases can cause nausea, drowsiness, breathing difficulties, and damage to the respiratory system. By taking proper precautions, you can protect yourself from any potentially harmful effects of SF6 and its decomposition products. We've covered the first steps toward protection by looking at properties and potential hazards of SF6. In the next part of this program, we'll look at measures that can be taken to ensure your personal protection. But before continuing, stop the tape and read the portion of your text on properties of SF6. Then answer the questions provided. Most of the time, you're going to have very little problem with SF6 and its decomposition products. The hazardous products are usually generated under the intense heat of arcing, and arcing typically occurs only during switching and during faults. In addition, gas-insulated switchgear is designed to keep the concentration of decomposition products at a relatively low level. Nevertheless, it's always better to take measures to ensure your safety than to take unnecessary risks. In this part of the program, we'll look at two aspects of safety: prevention and protection. We'll also look at treatment in the event that it's needed. A significant cause of hazardous SF6 decomposition products is moisture. An effective way to minimize the creation of decomposition products is by preventing moisture from getting into equipment. For outdoor SF6 insulated equipment, this means that the equipment should be opened only during dry weather conditions. If at all possible, the equipment should not be opened when it's raining or when the humidity is high. In addition, the equipment should remain open for as short a period of time as possible. Then, before the equipment is closed, fresh static absorbents or desiccants may be placed in special compartments inside certain gas-insulated equipment. Desiccants are materials that trap moisture that may be released from internal surfaces after equipment is closed and sealed. They also trap decomposition products that may be created during normal operation. After the equipment is closed and before it's filled with SF6, a vacuum is drawn. This is an effective way to remove surface moisture. Then, to remove any moisture that may have been absorbed into the breaker materials, a process called gas scavenging may be used. With this process, the equipment is filled with an extremely dry gas, such as dry air, nitrogen gas, or even clean dry SF6 gas. The gas is left in the equipment for a period of time so that it can draw absorbed moisture out of the equipment. Then the gas is evacuated and replaced with dry SF6 gas. Drawing a vacuum and gas scavenging are typically done using gas processing equipment that's specifically designed for use on gas-insulated equipment. Now, Prevention measures won't remove all moisture in decomposition products all the time. So it's necessary to take appropriate protective measures as required by your company procedures, or whenever you suspect or know that decomposition products are present. Taking appropriate protective measures means wearing and using proper protective equipment. Let's see what this equipment typically includes. Protective footwear keep decomposition products off of your shoes or boots so that potentially hazardous products aren't tracked off the site. Disposable pants and a disposable jacket help keep powdery decomposition products from contaminating your clothing. Face and breathing protection equipment can vary with the site and with company requirements. These workers are required to use an air-supplied respirator. The respirator protects the face and lungs from any possible decomposition products. And the air supply provides breathing air in case there is insufficient oxygen in an enclosed area. Other face and breathing protection that may be used includes a full face mask with an acid dust filter and an activated charcoal cartridge, or a self-contained pressurized breathing apparatus. Chemical-resistant gloves are essential for protecting the hands. And hoods and hard hats protect the neck and head. As an additional precaution, an emergency eye wash station should be available to flush the eyes, face, or skin if they're accidentally exposed to decomposition products. Protective equipment also includes cleaning equipment and materials. A vacuum cleaner is needed for vacuuming up any powdery decomposition products. The vacuum should have a disposable bag, and it should be used only for SF6 gas-insulated equipment. The vacuum should also contain micron filter elements. This filter is labeled as a high-efficiency particulate air, or HEPA filter, which means it can filter out very fine particles of material, such as the powder from decomposed SF6 gas. Disposable rags and cleaning solvents are needed to wipe down the inside of SF6 insulated equipment. Different solvents may be needed for insulation and for metal parts. Use only those cleaning fluids specified by the equipment manufacturer. Heavy-duty plastic bags are used for holding contaminated materials, such as rags, used desiccants, vacuum filter elements, and disposable protective clothing. If work is going to be performed inside of SF6 equipment, such as this large gas-insulated breaker, a portable blower, ventilator, or dry air supply will be needed to ventilate the equipment. In addition to the equipment that we just looked at, various utilities may require other equipment to be on site as well. An oxygen monitor, for example, or an oxygen supply and a person qualified to administer oxygen if it's needed. The important thing is that you have all the equipment and materials necessary for your protection on site and ready before you begin work. Prevention and protection are essential to the safe handling of SF6. Typically, when an injury occurs, it's because the people involved didn't wear the proper protective clothing and didn't follow safety procedures. But even if exposure does occur, long-term damage can be avoided by prompt treatment. As noted earlier in this program, if SF6 accumulates in enclosed or low-lying areas, the potential for suffocation exists. The symptoms of a slowly developed oxygen deficiency can include difficulty in breathing, a rapid pulse rate, poor muscle coordination, an inability to think clearly, fatigue, nausea and vomiting, and fainting. With sudden and acute oxygen deficiency, unconsciousness may occur immediately and without symptoms. The treatment for oxygen deficiency is immediate evacuation to an area where there is sufficient oxygen. In the case of severe oxygen deficiency or loss of consciousness, it may be necessary for a qualified person to administer oxygen. If decomposed SF6 gas is accidentally inhaled, there will be certain warning indications. The indications include a pungent and unpleasant odor, such as the smell of rotten eggs or a burning battery, eye irritation and tearing, a dry and burning throat, chest tightness, and skin irritation. The treatment is immediate evacuation to an uncontaminated area. If the warning signs are heeded immediately, the effects are reversible, and there is typically no long-term damage. Finally, contact with decomposition products should be avoided. The characteristic powdery residue is not always present in quantities that can be seen. These solid products can cause skin irritation and a burning sensation, and they may also cause breathing problems. The treatment for exposure to decomposition products is to leave the contaminated area and wash all exposed areas thoroughly with soap and lots of water. If there's any chance that the powder was inhaled, oxygen should be administered by a qualified person. Proper and prompt treatment are essential to reversing the effects of harmful exposure to SF6 and its decomposition products. But even more important, if you take careful steps to minimize the creation of decomposition products by keeping moisture out of the equipment, and if you take appropriate protective measures, treatment won't be needed. Now, in addition to prevention, protection, and treatment, proper handling is necessary to ensure your safety when you're working with SF6. In the next part of this program, we'll look at how to handle SF6 and its decomposition products. For now, stop the tape and read the part of your text on personal protection and answer the questions provided. When you're preparing to work on gas-insulated equipment, there are a couple of different ways that you can approach it. One way is to check the gas inside for decomposition products, either by taking a sample and sending it to a lab for analysis, or by using portable testing equipment. But not every utility has the facilities or means for doing this. The other approach is to assume that hazardous products may be present in gas-insulated equipment that has been in service. This is the approach we'll see in this part of the program as we look at how to handle SF6 and its decomposition products during routine maintenance and after a fault. The normal steps are followed for taking energized equipment out of service and making it safe to work on. In addition, welding equipment, heaters, flames, and smoking should not be permitted in the area while the gas is being handled. Gas that comes in contact with any of these heat sources can decompose and create hazardous decomposition products. Once the site is ready, gas processing equipment can be used to remove the gas from the equipment to be serviced. In outdoor facilities, gas has commonly been released directly to the atmosphere. However, this is not generally recommended by SF6 manufacturers. And with increasing concerns about the environment, direct release to the atmosphere will likely become less and less acceptable. Most gas processing equipment contains similar components. These may include a vacuum pump to draw used SF6 gas out of gas-insulated equipment and to pump clean, dry gas back in. A compressor to compress the gas for storage. Various filters to remove oil, moisture, and particulates from the SF6 gas. A refrigeration unit that cools the gas until it converts to liquid form so that greater quantities of gas can be stored. And a storage tank that holds the evacuated gas while the gas-insulated equipment is being serviced. If there's a chance that the gas that's to be evacuated contains decomposition products, an inline gas scrubber may be used to remove the decomposition products so that they don't enter and contaminate the gas processing equipment. The specific procedures for operating gas processing equipment will vary with the equipment. But there are some basic steps that are commonly followed. First, the gas is pulled out of the gas-insulated equipment. The vacuum pump is allowed to run until a recommended vacuum is drawn on the gas-insulated equipment. This helps to ensure that all the gas is removed. Then the discharge valve of the evacuated equipment is closed. The gas processing equipment is disconnected, and a dry air supply is connected in its place. Then the evacuated equipment is backfilled with dry air. The air is introduced slowly so that it doesn't stir up decomposition products as it enters the equipment. The air is allowed to fill the equipment until the pressure inside the equipment is equalized with the atmospheric pressure outside. After the pressures have been equalized, the equipment is left unopened for a period of about an hour to allow any powdery decomposition products to settle. Before the equipment is opened, all personnel must either put on the appropriate protective gear or leave the area. As an additional precaution, it's a good practice to recheck that the pressure is equalized in the equipment just prior to opening it. As soon as the equipment is opened, it's checked for the presence of decomposition products. Powdery byproducts aren't usually present in visible quantities unless severe arcing occurred in the equipment. The equipment should be vacuumed out as quickly as possible. Any powder that is present will absorb moisture from the atmosphere and can turn into a sticky gel that's more difficult to remove. After vacuuming, the equipment is wiped off with clean, dry, lint-free rags. Solvents or cleaners may be used only if they're specifically approved by the equipment manufacturer. If the equipment contains desiccants, they should be removed and placed in a heavy-duty plastic bag for later treatment and disposal. Used cleaning rags and other contaminated materials are also placed in heavy-duty plastic bags for treatment and disposal. After all decomposition products and contaminated materials are removed from the area, the equipment is ventilated to disperse any lingering gas before any additional servicing is performed. In most cases, normal maintenance or access to gas-insulated equipment involves the general procedures that we just looked at. It's very seldom that you'll need to work on gas-insulated equipment that has experienced an internal fault, and even more rare that a pressure relief device or the equipment itself ruptures as a result of an internal fault. But it's best to be prepared and know how to respond in case such a failure occurs. When gas-insulated equipment suffers an internal fault and ruptures, or its relief device ruptures, solid decomposition products may be present on and around the outside of the equipment. So, all workers must put on the proper protective clothing before approaching the contaminated area. To clean up the contaminated area, the decomposition products are vacuumed off of the failed equipment and any other structures, pads, and devices nearby that may have been contaminated. Then the equipment and surrounding structures should be washed down thoroughly with a neutralizing solution of soda ash and water at a mixture of about 1 pound of soda ash for each 10 to 11 gallons of water. If decomposition products have contaminated the ground surrounding the area, the products can be neutralized by rinsing it with the same solution. Then the entire area is thoroughly rinsed down with water. The procedure for opening and cleaning out the inside of faulted gas-insulated equipment is nearly the same as for normal access. But since it's known that decomposition products are present, and most likely in quantity, extra care is needed to avoid stirring up the powder and to get it cleaned up as quickly as possible. After gas-insulated equipment is serviced, whether it's a non-fault or a fault situation, the decomposition products and all contaminated materials and equipment must be properly cleaned or disposed of. We'll look at cleanup in the next part of this program. But first, stop the tape and read the section of your text on handling SF6 and its decomposition products and answer the questions provided. Safe handling of SF6 and its decomposition products doesn't end after they've been removed from gas-insulated equipment. There's still the matter of what to do with the decomposition products and contaminated materials that were collected. In this last part of the program, we'll look at general practices for treating and cleaning contaminated materials. During cleanup, full protective equipment should continue to be worn to protect against exposure to the decomposition products. The basic purpose of treatment and cleaning is to neutralize the acidic content of the decomposition products. This is accomplished by submerging and soaking contaminated materials in a solution of soda ash and water. A large plastic or metal container, such as this 55-gallon drum, is needed to hold the contaminated materials and neutralizing solution. Here, soda ash has already been placed in the drum. As a general rule of thumb, the amount needed is a quantity equal to about 1/4 of the volume of the material to be treated. Precise measurements are not critical. The contaminated materials are placed in the drum. These include the vacuum filter elements, the vacuum bag that contains the decomposition powders, the desiccant that was removed from the equipment, all rags that were used to clean the gas-insulated equipment, and the plastic bags in which the desiccant and rags and other contaminated materials were placed. Water is added to the soda ash and contaminated materials, taking care not to add it so forcefully that decomposition products are blown out of the drum. Enough water is added to completely cover the material being treated. Some instructions specify that water must be added until there is a minimum of 12 or more inches of water above the material. The important thing is that the material must be completely submerged and that there must be enough water and soda ash solution to neutralize and dilute the decomposition products. When water is added to the decomposition products, chemical reactions may occur that produce some heat and foam. This is normal. It's also good to prod or stir the contents to ensure that the water and soda ash solution mixes thoroughly with the decomposition products. The solution may bubble for a while until the decomposition products are sufficiently neutralized. In addition to the treatment of contaminated disposable materials, all non-disposable cleaning equipment must be thoroughly neutralized and cleaned. Some of the soda ash solution can be sucked through the vacuum hose to neutralize any particles sticking to the inside of the hose. Then clean water is vacuumed up to thoroughly rinse the hose. Fresh soda ash solution is also used to wash down the vacuum cleaner and any other tools that were contaminated with decomposition products. After the vacuum and the other tools are washed, they are rinsed thoroughly with clean water. Finally, after all contaminated materials and equipment are neutralized, the disposable protective clothing is removed and placed in the container with the soda ash and water solution. As with the other materials, the clothing is stirred to ensure that the solution reaches all contaminated parts. Then the materials are allowed to soak for a period ranging from 4 to 48 hours, long enough to neutralize the decomposition products. Some procedures also call for testing the pH of the solution. If the solution is alkaline, the material is harmless. If it's acidic, more soda ash may need to be added to neutralize the contents. Once the materials are completely neutralized, the neutralizing solution and waste materials are disposed of in accordance with any federal, state, and local regulations that may apply. Now, throughout this program, we've looked at the properties and potential hazards of SF6 and its decomposition products, and we've seen how to handle them safely. Working with SF6 and its decomposition products is not so different from, say, working with oil-filled equipment or working around energized equipment. If you know what you're dealing with and how to respond to various situations, you'll be able to perform your job confidently and safely.